Somewhere in the universe, at the very center of a galaxy, there exists something we cannot see, yet everything around it is forced to obey. It does not shine. It does not announce itself, but stars orbit it at impossible speeds, and even light must bend as it passes nearby. For decades, we have called it by a name that sounded final, reassuring, and certain, but the more precisely we observe it, the less certain that name becomes. Because if it truly were what we think it is, then right at its center, the laws of physics themselves would have to break. And now, the question is simple. Are you ready to hear its name? Before anyone tried to define what this object was, scientists had to accept a more basic truth. They could not see it at all. There was no image, no visible surface, no glow coming from the center of the galaxy. Telescopes showed nothing unusual at that exact location. What caught their attention instead was motion. Stars near the galactic center were not moving the way astronomers expected. Their paths curved sharply, as if pulled towards something that could not be seen. Some stars appeared to swing around an empty point in space. These patterns did not appear in just one place. From the 1,970 seconds through the 1,990 seconds, similar motions were observed in more and more galaxies. The details varied from galaxy to galaxy, but the behavior was consistent enough to raise a serious question. Astronomers slowly realized that something unseen had to be influencing these stars. But at that stage, the evidence was still indirect. Because of that uncertainty, early models were careful with language. The safest approach was to call it a massive object at the center of the galaxy. In some studies, it was treated almost like a planet taken to an extreme. In others, it was left deliberately unnamed, waiting for better data. What matters here is this. The story did not begin with certainty or with a bold label. It began with strange motions and unanswered questions. With what we know at this point, it still doesn't look like anything dramatic. There is no image, no surface, just subtle clues hidden in motion. So let's pause here for a moment. Based only on these early clues, do you still think of it as a planet? And if you do, what kind of planet are you imagining? Keep that answer in mind, or leave it in the comments. Before we add the next piece of the puzzle, as observations improved, astronomers didn't just see stars moving strangely. They began to measure how fast those stars were moving. By the late 20th century and into the early 21st, instruments became precise enough to track individual stellar orbits near galactic centers. These stars were not drifting randomly. They were racing around the center at enormous speeds, completing tight, fast orbits. From those velocities, physicists could finally do something decisive. They could calculate the mass of whatever was sitting at the center. And that's where the idea of a planet quietly broke apart. The numbers were not slightly bigger than expected. They were catastrophically bigger. The inferred mass was millions of times greater than Jupiter. Not thousands, not tens of thousands, millions. At that scale, the word planet stops meaning anything physical. There is no known process by which a planet can accumulate that much mass. And even more importantly, there is no way for an object that massive to stay dark and quiet. Something with that mass should heat up, ignite, or tear itself apart. Yet this object did none of those things. Faced with that contradiction, astronomers had no choice. The planet idea was no longer unlikely. It became impossible. From this moment on, the conversation shifted. Whatever this thing was, it had to belong to a different category entirely. Not planets, not stars, but something far more compact and far more extreme. So let's stop again and update the guess. With a mass like that, do you still keep the answer planet? And if not, what do you think this object actually is now? Leave your updated answer in the comments before we move on. Once the planet idea was ruled out, attention shifted outward, not inward. Scientists stopped asking what this object was made of and started asking how it affected everything around it. And that's when the picture became unsettlingly familiar. Light passing near the center did not travel in straight lines. It bent. This bending matched exactly what general relativity predicts when space-time is warped by an extremely compact mass. Gas and dust falling toward the center didn't drift gently inward. They spiraled violently, forming a flat, rapidly spinning disk. As that material heated up, it released enormous amounts of energy before disappearing into the dark central region. And that center remained silent. No surface, no radiation coming directly from it. Just a dark core where emission abruptly dropped off. Every major observational test lined up. The lensing, the disk, the darkness. One by one, they matched the same theoretical models. From the outside, there was nothing left to argue with. This object behaved exactly the way a black hole is supposed to behave. As the data piled up, the language began to change. Papers became more confident. Headlines became more decisive. Textbooks followed. What was once an unnamed massive object at the center of galaxies now had a clear label. And at this stage, most people stopped questioning it. The mystery felt solved. So let's be honest for a moment. Right here, with everything matching so cleanly, did you just switch your answer? Did you just think it must be a black hole? If so, you're not alone. Let me know in the comments before we go further. Up to this point, everything we've discussed lives on the outside. Motion, light, disks of matter, shadows, all observable, all measurable. But the moment you accept the black hole answer, you inherit something else along with it. Something hidden. At the center of a black hole, the equations demand a singularity, a point where density becomes infinite, not extremely large, not unimaginably dense, infinite. And in physics, the word infinite is not a triumph. It is a warning sign. Whenever a theory produces infinities, it usually means the theory has been pushed beyond where it actually works. At the singularity, general relativity stops making sense. Space and time lose their meaning, but quantum mechanics cannot step in to help either. The conditions are far beyond where quantum theory has been tested. What remains is a region where our two most successful theories both fail. Modern physics is deeply uncomfortable with that idea. A point where every known law breaks down is not considered an explanation. It is treated as a placeholder, a sign that something is missing from the model. And this is where the certainty begins to crack. From the outside, the black hole works perfectly. But on the inside, it demands a place where physics itself gives up. That doesn't automatically mean black holes are wrong, but it does mean the answer might not be complete. So here is the real turning point. If a black hole requires a region where our best theories collapse, is that really the final answer? Or could there be another possibility? One that looks the same from the outside, but avoids this mathematical breakdown entirely. Take a moment and think about it. With this new clue, do you still stand by black hole? Let me know before we move on. Once the singularity becomes a problem, the question changes again. Not what we observe, but what could exist inside without breaking physics. And here is the key point. Physicists don't need to invent something new to answer that question. The mechanism already exists in modern physics. It just usually appears in a very different context. In cosmology, there is a well-established idea known as negative pressure, unlike ordinary pressure, which pushes outward or resists compression. Negative pressure behaves in a counterintuitive way. It does not pull matter inward. Instead, it resists collapse by acting as a form of gravitational opposition. This idea is not speculative. It is already used to explain something on the largest possible scale. The accelerated expansion of the universe itself. That expansion is driven by vacuum energy, an energy built into space itself, carrying constant energy density and negative pressure. Now, imagine applying that same concept not across the universe, but inside a compact object. Several theoretical models show that a core dominated by vacuum energy could remain stable. No singularity, no infinite density, just a balance between gravity pulling inward and negative pressure pushing back. From the outside, nothing dramatic changes. Light still bends. Matter still spirals. The shadow still forms. Observationally, it would look almost identical to a black hole. The difference lives entirely inside, hidden from direct view. And this is why the logic holds together. No new forces. No exotic assumptions pulled from nowhere. Just familiar pieces of physics connected in an unfamiliar way. So let's pause one last time before the reveal. If the core of this object is not matter at all, but the energy of space itself, what concept are you thinking of right now? Leave your guess in the comments before we say its name. At this point, the picture is finally complete. All the clues line up without forcing the laws of physics to break. An object that bends light exactly like a black hole, that pulls stars into tight, fast orbits, that feeds on surrounding matter and leaves behind a dark central region. But inside, instead of a singularity where physics collapses, there is something else entirely. A stable core, not made of matter, but made from the energy of space itself. This idea is not science fiction. It comes straight from solutions of Einstein's equations. Physicists already have a name for this kind of object. It is called a gravitational vacuum star, often shortened to gravastar. From the outside, a gravastar is almost indistinguishable from a black hole. The same lensing, the same shadows, the same violent environments. But on the inside, the story is completely different. No singularity. No point where physics gives up. Just a balance between gravity pulling inward and vacuum energy pushing back. If gravastars exist, they don't just change how stars die. They change what we think is sitting at the hearts of galaxies. And they may even connect to something much larger. The force driving the universe itself apart. So the real question is no longer whether black holes exist. It's whether some of them are actually something else, hiding in plain sight. And that question doesn't end here. Because if gravastars are real, the next mystery is even bigger. How would we ever prove it?